Hi, this is Professor Carter. This is the seventh video on the neoclassical theory of production and distribution. In the last video, we developed the theory of the cost of production. Remember that what we're looking at here is going to be the choice of technique for the producer, which is going to be the producer's equilibrium. What has to happen is that on the production side, the relations have to come into equality with the cost side. The production side relation is going to be the marginal rate of technical substitution, has to come into equality with the cost side of production. We're going to see is going to be equal to the factor price ratio. Okay, we had our ISO cost line, which we had our, we have our income equation. It says that the total cost is equal to the cost of capital. Note that this PK star includes the generated profit. Multiplied by the quantity of capital for the total capital cost plus the wage rate times the quantity of labor for the total wage cost. We're going to express this in factor space, right? The same space that we have our marginal rate of technical substitution. And in order to do so, we have to solve for K in the total cost curve. Solving for K in the total cost curve gives us the ISO cost line. Here, the vertical intercept is going to be the total cost or the price of capital. The horizontal intercept is going to be the total cost of the price of labor, the wage rate. And the slope is going to be the wage profit, or the factor price ratio, I should say, wage rate over the price of capital. Here I draw the ISO cost line for the same money cost, but different wages, different ratios of wages to capital. You have a high wage ISO cost line, which is going to be steeper, and you have a low wage ISO cost line, which is going to be flatter. And what we're going to see when we look at the producer equilibrium is we're going to see that the optimizing technique of production is going to be the technique of production that moves along the envelope of the different factor prices. In other words, that as the factor prices change, so too will the technology. I'll explain what I'm talking about here. Okay. So now we introduce producer equilibrium. Okay, so we say, all right, this is going to be here. We'll call this number 6. Okay, this is going to be page 6 here. This is going to be producer equilibrium. All right, this is also equilibrium. Okay, this is going to be the optimal technique chosen. All right, the optimal technique chosen. All right, the choice of technique. Now we're gonna assume that the technique that's going to be chosen is going to be chosen according to the behavioral assumption associated with a well-behaved, profit maximizing, cost minimizing producer. All right, so we'll draw. This is going to be adjudicated, if you will, in factor space. Okay, so we have the factor space here. We're going to have a vertical axis. The horizontal axis is the quantity of labor. The vertical axis is going to be the quantity of capital. We're going to have the isoquant is going to be here. All right, so this is going to be our isoquant, which is going to be here. This is going to be the constant quantity of output, okay? And then the budget line, okay, the ISO cost curve, all right, is going to be here. All right, this then becomes the budget, which then becomes here, okay? And so you can see where the two shall meet. Okay, this is going to be the optimal condition. This is then the equilibrium bundle, or the equilibrium technique, which we're going to call epsilon. All right, so epsilon here is going to be the equilibrium technique. And at this particular technique, you can see that the isoquant comes into tangency with the ISO cost line. In terms of the math, this means that the marginal rate of technical substitution capital for labor, which is equal to the marginal product of labor over the marginal product of capital, which is equal to the partial derivative of output with respect to labor divided by the partial derivative of output with respect to capital, that is equal to the wage profit relationship. All right, the wage profit, the factor price ratio. All right, so what you have is this. All right, you have the equilibrium on the production function side. This is the production function side of the equilibrium, which is going to be the marginal rate of substitution. This is the cost side of the equilibrium, which is going to be the factor price ratio. And at that point, and in that point alone, do we have the tangency solution, and there the optimal condition is going to be here. Okay, that means that we're going to have an equilibrium quantity of capital chosen and an equilibrium quantity of labor chosen. Okay, so this is going to be the quantity of capital epsilon. This is going to be the quantity of labor epsilon. Epsilon is going to be the optimizing technique given the particulars of this situation here. And then that means that we can take the ray from the origin. Okay, here. We could take the ray from the origin here. Okay, this is going to give you the optimal capital labor ratio or capital labor ratio epsilon. This is going to be the epsilon technique, all right, where the epsilon technique is going to be producer equilibrium. All right, producer equilibrium. Okay, that's going to be the technique that's going to be chosen, is going to be that technique there. Okay. Then we consider what happens when the technique, when the prices change. All right, we already saw that with respect to our budget line. Right, we saw that as the wage goes down, the budget line gets flatter. All right, so we draw this in terms of our factor space. All right, this is going to be the quantity of capital of labor on the horizontal axis. This is going to be the quantity of capital on the vertical axis here. Okay, we're going to have the original quantity of labor. The original wage rate, I should say. All right, factor wage ratio. That's going to be at the high wage regime of distribution, and then we're going to have the wage is going to decrease. Okay, so then we have a wage at the lower quantity of wages. Okay, and so what we're going to see here, all right, is that we're going to see that as we have a change in the factor prices, we're going to have a change in the techniques of production, okay, which is going to be there. This is going to be when the wages are high, the optimal technique, epsilon 1, is going to be the capital intensive technique, all right? This is going to be the capital intensive technique for equilibrium 1. This is going to be the labor intensive technique for equilibrium epsilon 1, okay? This is going to be as the wage goes down, okay? This represents the equilibrium quantity of capital and labor, the equilibrium technique at the lower wage. This becomes the equilibrium quantity of capital at the lower wage, and this becomes the equilibrium quantity of labor at the lower wage. And you can see at the lower wage. Okay, you can see that as the wages are higher, and then remember, this output is going to be the same. All right, that's going to be the same output along that isoquant here. Okay, so this says that the marginal rate of technical substitution capital for labor is equal to the marginal product of labor over the marginal product of capital for the first technique is going to be equal to the wage profit relation, or the factor price ratio for that first technique. And then also for the second technique at the lower wages, you can see that the technique is going to change. All right, the marginal rate of substitution capital for labor of the second technique is going to be equal to the wage rate. all right, of the relative wage rate of that second technique. All right, so you can see we have that relationship there, that as wages go down, the quantity of labor purchase goes up and the quantity of capital purchase goes down. And it's that which allows us to construct, in this case, is going to be the downward sloping demand curve for labor. All right, so we put on the same horizontal axis the quantity of labor, and for now we're going to, except for now, instead of putting the quantity of capital on the vertical axis, we're going to put the price of labor. All right, that relative price here, W over PK star, is on the vertical axis, and then you can see here that the quantity of labor is going to be associated with the different wages, that as the wages are higher, the quantity of labor is going to be lower, and as the wages are lower, the quantity of labor is going to be higher. And so then you can draw your labor demand function. So your labor demand function is going to be drawn here, right here. Okay, this is going to be the higher wage rate, W over PK star 1, and this is going to be the lower wage rate, W over PK star 2, right, which is going to be right there. This is going to be 1. This becomes your labor demand. This is going to be the quantity of capital, of labor in the first equilibrium position, the quantity of labor in the second equilibrium position. And so what we're able to do then is, with all the assumptions that we have here regarding the producer technique, we're able to draw the downward sloping inverse law of demand for labor. Now, the whole point of capital theory is to try to explain that when we're looking at the concept of the quantity of capital, this downward sloping demand function for capital doesn't hold in the general case. And so this is where we move into when we start looking at the application of this for the Cambridge controversies, etc. Okay, right on.